Alright, so moving on here, I'm installing the overbridge with a rubber grommet to pass through the wires from the transformers up to the components up top. And I'm going to be wiring those in where they belong, the ground leads, the power leads, and the filaments from the heaters to the jumpers that I have already installed, the green wires across the top there. And I'm also going to install the input jack and its various components on there, as well as the volume and tone pots. Now, I'm also well aware that I'm up to part 6 on this video, and you're just watching me do a lot of work and a lot of soldering 16 times faster than real life. And we haven't even gotten to the good part yet, which is, does this thing even work? So I am going to fade a lot of this out and just take my word for it. I'm doing all this work. And let's get to the good part where I'm testing things. Alright, so first things first, I have my volume temporary knob on, temporary tone knob, and then this is be my gain, trim, whatever you want to call it, knob. First things first, we plug it into the current limiter, which is that light bulb back there, and we turn the thing on. Oh, I need a fuse. Hold on. Need a fuse. Alright, so I have a fuse. Didn't know that. I got everything here turned all the way down. I'll put the tone right up the middle because I know I'm going to do that anyway. Plug it into the current limiter. Turn that off. Now, if it starts drawing too much current, that light bulb will light up. And it should light very brightly if it's drawing too much current. If it lights up very dim or not at all, then I've got everything right, and I know that I'm not going to worry about it drawing too much current. If it is drawing too much current, it all gets absorbed by the light bulb rather than the tubes or the transformers or anything else in here. I've been through this and I think everything's going to come out right, but once it passes this test, then I move on to the actual power supply, or the variac here. I'm going to set it to 120 volts, and then we do our actual testing. But I need an output jack. Let's see, 4 and 8. And do I need an input? Not for this test, I don't. Tubes, duh. Hey, that would help a lot. Tubes. Alright, here goes nothing. Pilot lights on. I hear a slight hum. I don't see anything on that current limiter bulb. That's good. So it's not drawing too much. Turn it up. Cool. Turn it off. That hum bothers me. That's what I was trying to get rid of with that extra filter stage. Alright, let's set up the variac for 120 volts. Turn it up. 118. 120 volts. Look at that. Right on the money. Alright, so now plug this in here. See what we got. if I turn this up to 5, I still shouldn't hear anything because I got this turned all the way down. So there it is, halfway up. Good. Turn this up. I hear it. And it's already distorted. There's 5 on there. Wow, that's bitey. All right, leave that in the middle. Wow, so it's about 3 where it starts to distort the preamp. That's interesting. Jesus. Yeah, that's what I thought. Okay, let's not do that. Okay, so after playing through it, the results weren't what I desired. It's much brighter than I expected, with not a whole lot of low end. The preamp distortion comes in a lot earlier on the knob than I expected. I expected it to be somewhere around 5 or 6. Here it comes in at about 3. And if I turn the volume all the way up past 8.5, 9, it starts to squeal. I get this nasty squeal. And that's regardless of what I'm doing with my voltage divider circuit here. This is where tweaking it comes in, and it's easier and much less tedious for you, the viewer, to just hear what I'm going to do and then let me do it rather than watch me do it, because it's just me fiddling around in here a lot. But I need to tell you what I've done already. One thing I didn't tell you or show you was me taking voltage readings throughout the amplifier. I'm happy to say that practically everything turned in exactly where I was expecting it to, or at least well within reason of where I expected it. The one thing that I'm a little off on is the plate dissipation for this EF82. Now, what is plate dissipation? It is literally how hot the tube gets. Just like an old incandescent light bulb, it's measured in watts and it's rated to a certain wattage. The max plate dissipation for an EF80 tube is 2.5 watts. Once I took the measurements, it came out to 2.56 watts. So it's slightly over. Most people would say that's close enough, just leave it alone. But I think that's a little high, and I want to lower it just a little bit. So what I did is I changed out the 560 ohm resistor to a 620 ohm. That should lower this whole thing down to about
2.25 watts, which is still close enough and well within where it ought to be. It's not going to get too hot and go bad too soon. The other thing that's a little unsettling for me, more so actually, is I took measurements on the voltages on my filaments, on the heaters. They came out just over 7 volts. They're supposed to be 6.3. That is more critical for the life of the tube. That's too hot. And the only way to change it is by adding in a resistor. Now you can do some Ohm's law, mathematics, and I have to put in a 1.5 ohm resistor on each leg to lower it down about 0.8 volts, which would put me just about 6.2, 6.3, which is right where I want to be. And the only way to do that is I got to take this thing out of here, or at least remove this somehow or other. Let's move this light over here. Remove this somehow or other. Drill a couple of holes here, put in another couple of eyelets, and I've got some 1 watt, 1.5 ohm resistors that I can strap across here, and then take one of these legs off and take it to there. So I got voltage coming in, over to the resistor, and then back out to the tubes again. And I have to do that on each leg. That's a little bit of work. The other thing I've already done is, in order to address some of the trouble, the brightness that I have in here, I thought, well, maybe these 10 UF caps are cutting off a little bit too much low end. So over here on the preamp, on the first gain stage of the first triode, I took out the 10 and I put in a 22. This should take it down to like 10 hertz, really, really low. So I'm getting all the low end I can get into the circuit. Another thing I did to try to kill 2 birds with 1 stone is I wanted to lower the gain just a little bit. I swapped out the 1 meg volume pot for a 500K volume pot, and I removed the treble bleed that was on the volume, and that helped with some of the brightness. Not tremendously, but it definitely helped. But there's more work to do. Like I said, I have to do this thing with the heaters for sure. Another thing I'm going to try, is I'm going to take this bypass cap out. This is on the second triode, so the second gain stage, take it out. That'll lower the overall gain for sure. But I think it might be too much. So in order for me to get the touch sensitivity and things that I want to get out of this, I think I'm going to swap this 100K out for a 200 or a 220. This will put more pressure on the plate, keep the voltage on there, and will gain it back up again. So I'll have a lot of input sensitivity by boosting that up and taking that away. I think that'll be a nice balance. So that's the next thing I'm going to do. Then, of course, I have to take voltage readings again to make sure I'm where I think I'm at. I think I'm good with the voltage readings. Changing this out to a 620 is definitely going to help. But yeah, that's what I'm doing next.
So a lot has happened since last we spoke. I wasn't expecting the preamp to start distorting at around 3 on the dial, because I'm not a big fan of preamp distortion, because it adds a lot of fuzz to your tone, and I'd rather have saturation and push rather than fuzz. So reluctantly, I had to go back and reduce preamp gain in order to keep the distortion down. Well, that was the whole purpose of me changing the circuit, because the last time I had reduced preamp gain, and I wanted to get away from that. I wanted push, but I didn't want fuzz. So after trying several different things, removing bypass capacitors, changing plate load resistors, I got to the point where I almost literally put it back to the original circuit. I did move the tone control back in between the preamp tubes, moved it from after to before the second triode. That actually makes a difference. And the reason it's better this way is because the volume control really needs to be at about 50%. about halfway in order for the tone control to actually work. The two go together. And if I have to set my voltage divider at 80-90%, then I'm not really getting much swing on the tone control. So I have to move it between the two triodes in order for it to work more or less at all. I was expecting to set my voltage divider at about 20%, meaning I'm taking 80% of the signal out. Even with the preamp the way it is, I still have to dial back the voltage divider to about 8 on the knob. It's almost all the way up, but not quite. And that's not enough to get the tone control to work. So right now, I have no bypass caps on either one of the preamp triodes, and it distorts right around 8, which is right about where I want it. But I'm overall still not happy with the tone. So I've got something else I want to try.
One of the things that's so fascinating about this modern age we live in, with science and technology and the web and everything, is that you have access to tools that the original amp manufacturers never even dreamed of. Such as this. This is a program online called TSC in the web. TSC stands for Tone Stack Calculator. And what it is that it is a tone stack calculator for all these different amplifier manufacturers. And you just come up here and you use the little drop down and you can look at all these different tone stacks
that are used in all these different amplifiers and how it affects the signal.
For instance, back to Marshall. This is the schematic for the Marshall Tone Stack TMB, treble, mid, bass. You can interact with them, see how they work. And everything in here is completely customizable with these little drop downs, or you can hit edit and change any single one of these component values here and see what it does. This is awesome. So here's what I want to do with my amp. Right now, this is the mid-scoop circuit that I have in it. With these component values, and I'm centered on about 470 hertz, and it's very similar to what the Fender TMB circuit is. This is a black face Fender tone stack, and if you pop between these two, you can see that they're centered, they're similar, except for one big thing. You'll notice how wide a scoop this is from here to here. That's a real wide scoop, whereas mine is more or less a notch. It's okay on the low end, but this high end jumps up pretty quick. So this is kind of notchy. So what I want to try to do is go over here to the Bassman 5F6A. This is one of the most coveted amplifiers in the world. Many people say this is the perfect guitar amp. So one of the things I want to show you here is just how wide a scoop this is. If I'm here at 100 hertz, it doesn't get flat again until I get clear up here into about the 6K range. And that's a pretty big scoop they got going on right here. And so instead of this, I want it to look more like this. You also notice that the center frequency is different. This is about 700 hertz. This is about 470. It makes a big difference. So I went here to the Framus mid control. I adjusted the component values to simulate the Bassman. Here we are at 700 hertz. And that scoop starts at 100 hertz, and again, it doesn't get flat until about the 6K range. So if I pop between the two, They're very similar. And it won't take much to recreate this on my little tag board. This whole thing starts at about 10 dB down. And then I'm going to lose another 10 dB by the time it gets from 100 Hertz down to about here. So this is 20 dB down right off the bat. I've got plenty of headroom now that I've taken both bypass capacitors out. This will take out a good amount of gain all on its own. So I can put more gain into it and bring that signal back up. But I want to hear what this sounds like. This is something I've been thinking about doing for a long time, and I think this is a great amp in order to give it a try. Not that I expect this to sound exactly like a Bassman, but it will be in the ballpark of a known good amp. So that's what I'm going to put in here next. So this is with the 5F6A Bassman circuit in it, the mid scoop, and I also have a 150 picofarad treble bleed cap across the volume knob, add a little treble into the top end, and this is with both cathodes with a bypass. This is the volume halfway up and the tone halfway up. Just starting to break up in the neck. Not bad. Volume's on about 7. It's about 8.5. But it's still, it sounds a little hollow. I think I'm scooping out too much mids. Yeah, I'm definitely taking too much mids out. Les Paul and Humbucker's got to have more mids to it. So, I also built up this other circuit based almost identically on that one, but this one has, the Bassman's got 9 dB of scoop, this one's got 6 dB of scoop, so I'm gaining 3 dB, plus the overall gain of this is up by about 1.5 dB, so really I'm getting about 5.5 or more dB of gain with this one, as well as more mid push. So I'm going to try this one next. I'm going to swap that one out and leave everything else the same and see where we're at. Alright, so it took me about 10 minutes or so to swap it out, and this is what it sounds like. I've only got the one bypass cap on, but let's hear what this sounds like. I need to explain what I'm doing here. And it looks like I'm just playing and noodling, but I'm actually listening pretty critically. I'm listening to pick attack response. I'm listening to, is my picking clicky or not? And in this case it is, which means that some frequency is getting enhanced more than others. I'm listening to the overall tone as far as how much bass response versus how much upper trebles. And yes, I know I have a mid scoop, but is it where I want it? I'm trying it with different pickup positions. I'm trying it with different guitars. All right, that's not bad. It doesn't sound like I got a big hole in the middle of the frequencies anymore. Let's see what happens when I put this other bypass cap back on. Now remember, this is up all the way. Wow. 5. And I'm also testing the tone control to see how it responds at various gain stages. I'm listening to the tone with less gain, medium high, and high gain. All of this matters as far as what makes a guitar amp sound good. That's quite a lot. Interesting. I'm gonna have to play and think about this. Alright, so I temporarily put in a 10K negative feedback resistor coming off of the output jack back into the cathode of the second gain stage, which is 180 degrees out of phase. And I have a 10K on there because if you just put it all in there, it would just kill the signal and it would just make everything a horrible mess. So you put a resistor on there, and what that does is it controls the gain. And it takes just a little bit of an edge off of the high end. And many, if not all, amplifiers have such a thing. I tend to not use them because I kind of like the raw sound. But for this, I think this really helps. That's at about 6.5. Here it is at 8. Try it with different guitars.